Okay, so next we're going to talk about exponential growth models. And this is where they give us our growth as a percentage rate. So our function is y equals a times 1 plus r to the t. So this is a plus sign. This is the letter r. Okay, so this looks scary because it's a whole bunch of letters, but it's not so bad. So a is just however we have to start with, and usually these are about money, so typically this is going to be our dollar amount. We're investing in a bank or whatever. How much are we starting off with? So we call this the initial amount, and it's our y-intercept, so it's the point 0, a on a graph. And then this is the same as a times b to the x. Okay, so our a is still a. Our b, because we have this percentage rate, we're having to take it and add it to our whole. So we're keeping our whole plus getting a little bit more. So our rate is that percentage rate. And we have to take our percent and switch it to a decimal. So for instance, 5% is going to become 0.05 in here. And then our t is our time. And typically that's in years, not always, but that's kind of the most common that we'll see. Okay, so there's our model. So let's do an example. Let's say that we have $1,000 and we want to invest it, and we get 4% annual interest as our rate. So we're going to write our function. So y equals a, my starting amount is $1,000 times 1 plus, so I'm keeping my whole $1,000 plus I get another 4% every year. Okay, to the t, or x, but we use t because time. But if you used x there, that's fine. Okay, so here's my function, and then I can simplify this right here. So y equals 1,000 times 1.04 to the t. So this is how we go from getting this percentage rate to then being able to write it just as a times b to the x. And oftentimes, because multiplication and the decimal can be confusing, we'll still write this in parentheses, but it's the same idea. We're back to that a times b to the x. Okay, now let's say they said, okay, well, how much money am I going to have in the bank after 10 years? It's a common thing they'll do. They'll say, here's my amount, here's my percent, how much will I have after a given amount of time? So 10 years, so we're going to go y equals 1,000 times 1.04 to the 10th. So our 10 goes in for t because that's our time. And then I'm going to use order of operations. So my first thing I'm going to do is I'm going to raise my 1.04 to the 10th power. I'm going to show you on the calculator how I'm going to do this. So 1.04, and I'm going to use this little caret button or the exponent button and type in my 10. Okay, and so here's my new number. Now, I'm just going to write it like this for now because I don't want to have to write all of this information, but I am not going to round that number until the very end because I don't want to lose any information. So I have this, and now So I did my exponent step. Now I'm going to multiply. So to multiply on the calculator, I'm just going to hit times, and it's going to bring down that answer with all of those digits. I don't have to retype it. So times 1,000. And so my answer is 1480.244, blah, 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 blah. Now, we are talking about money, and I'm at the end of my problem. So now I'm going to go ahead and round, but I'm going to round to the nearest penny because that's how we deal with money. So it's going to be 1480.24 dollars is how much I will have. So that's a pretty nice deal. So $1,000 at 4% after 10 years, I've made a good chunk of change there. That's kind of nice.